All right, so we are more than halfway through the chapter of volume and surface area. We're done with volume, and we're moving on to surface area. So I'm pretty sure you have experience with surface area. I know maybe not with to the extent, I should say, of the shapes that we're going to be looking at now, which is part of the reason why we're doing this intro. But you at least have a conceptual understanding, I should say, of surface area. So the best example I can think of surface area is wrapping a box with wrapping paper. So if you have a rectangular prism shaped box or even a cube shaped box, and you have the length and the width and the height, so we're still talking about three-dimensional solids, but surface area is a two-dimensional measure because it has the word area in it. So I'm not talking about putting something inside the box. I'm talking about covering the outside of the box with either paint or paper in this case. So again, the best example I can think of surface area is wrapping a package, putting paper on a package. So how can the surface area of a cylinder, is what we're looking at here today, cylinder, be determined? Looking at the surface area of a cylinder. So just a few refreshers before we kind of get into the nuts and bolts here. First of all, let's kind of take a look at this example. Naomi, that's her right there, I guess, is eating some frozen yogurt. And then when she's done with that, she cleans out the container or whatever, and she's going to use the container for a school project. The container is shaped like a cylindrical tub, okay, so it's a cylinder shape, with a diameter of 20 centimeters and a height of 30 centimeters. So I need to know diameter and height. She wants to know how much paper she will need to cover the entire container. All right, so we're starting with a real-world problem, and then we're going to kind of address the ideas that are related. First of all, the word is net. This is a vocab word. I'm sure you've heard it before. I know you've heard it in 6th grade, maybe 7th as well. It says that nets are two-dimensional patterns of three-dimensional figures. In other words, it's kind of like a blueprint of a 3D solid if you opened up the 3D solid and laid it out flat. So you're decomposing, it says, the 3D figure into separate shapes, and you can use the net to find the area of each of the individual shapes and essentially add them all together. So here is an empty cylinder container, apparently of oatmeal. I'm sure you've seen the Quaker guy with the hat and the white hair, Quaker Oats, so something like that. It's a cylinder-shaped figure. So we have use an empty cylinder-shaped container that has a lid. What is the height of the container? Well, let's just use the dimensions that they gave us here. It's kind of the easiest way to do it. So it tells us that the height is 30 centimeters. That means top to bottom. So from there to there, 30 centimeters. I apologize. Whoops. Uh-oh. Don't want that. Sorry. 30 centimeters. From there to there. That's the height. Okay? Diameter is 20. We're not really concerned about the diameter. We're concerned about the radius. So here's what would happen. Let's imagine that we're, excuse me, take the lid off, cut the circle out from the bottom, and then make one cut vertically here so that you can roll out the cylinder shape and make it flat. Okay? So basically, without, answering all these questions, kind of helping to move this along a little bit, what are the shapes that make up the net of the container? Okay, so you should have the top that came off and then the bottom that came off, so you get another circle right there, the top and the bottom. And when you cut this and lay it out flat, I think we mentioned, like, if you unfold the piece of paper, you have a rectangle. So what are the shapes that make up the net of the container? You should have two circles and a rectangle. There you are right there. Okay, if you want to draw that, great. If not, no big deal. You can visualize it. Okay. But you have two circles and a rectangle that make up the net of the figure. So these are kind of tedious questions that we're just going to kind of glance over a little bit. It mentions how to find this. So the idea here is if you take the top and put it on top of the rectangle that you rolled out and you folded this back around, this rectangle should fit perfectly all the way back around the circle. So basically that means that this should be the circumference of the circle. Okay, distance around. It should be the circumference of the circle, whatever that measurement is. Okay, if I fold it back around the circle, if that makes sense. So find the area of each shape. The top, Okay, so we're going to get into some area formulas of circles. Area formula of a circle, just as a reminder, area equals pi r squared. Okay, so for right now, I know we've spent a lot of time in our book using the actual value for pi, and on IXL using 3.14 for pi. From this moment forward, or actually for right now, we're considering maintaining just the consistency of what we were doing in volume and using the actual value and then rounding whenever we have to. So if I was going to find the area of each shape, okay, the top and bottom would be the same. The two circles are exactly the same size. And it said my diameter was 20, which means my radius is 10. So if I do pi times 10 squared is 100, right? So it should be 100 times pi, which 3.14 times 100 is going to be 314. So 314 and some change. We'll round it to the nearest 10. 314.15, so it's 0.2. So that value, the 314.2, goes both here in the top and on the bottom. Okay, 314.2 for the top, 314.2 for the bottom. And it says the word side. The side means the lateral area. So that rectangle that's going, whoops, sorry, 3, 4, there's no decimal there, 314.2. Sorry about that. So the side then would be the area of the rectangle, which is the circumference of the circle, which is pi times diameter. That's a reminder from before. So C equals pi times D. It's also 2 pi r if you happen to have the radius, because the diameter is twice the radius. So the circumference of the circle is pi times diameter, so this is going to be, they gave us a diameter of 20, right? So pi times 20. And that's 62.8 if I round it. Okay, and the circumference of the circle, remember when I lay this out, is one dimension of the rectangle. The other dimension of the rectangle is the height of the cylinder, which they said was 30 centimeters. So this is the C for circumference. That's the 62.8 that we're talking about, right? The 62.8 is here. And this would be the height, which is 30. So length times width would be the 62.8 times 30. Area equals length times width. And that gives me 1885.0. You can calculate that yourself. At this point, if you're confused about anything, now would be a good time to stop. Rewind if you need to, ask questions if you need to, because if you don't understand it to this point, going forward is going to be rather difficult. So all I've done is found the areas of the individual shapes. The top and the bottom are circles. The area formula for a circle is pi r squared. The radius was 10 because the diameter was 20. So I find the radius by cutting the diameter in half. Square that, which is 100, multiply it by pi, and round that to the nearest tenth. I get 314.2. There are two circles, the top and the bottom, that have the same area, this area right there. So we filled that in. I apologize for the illegibility. Then the third shape was the rectangle that we got from unfolding it, unwrapping it, whatever you want to call it. And that is the circumference times the height. All right, so pi times diameter gave us the 62.8. That was this dimension right here when I roll it out. And the other dimension was the height of the cylinder, which was 30. I multiply 62.8 times 30 because the area of a rectangle is length times width, and that gave me my 1885. Find the sum of these areas. Okay, so then we're just going to add that up. 1885 plus 314.2 plus 314.2, and I get a grand total of 2,500. Whoops, let me try that again. 2,500, 13.4, and I need to label it. I measured it in centimeters, so I'm going to put the label centimeters, but I saw the word area in there, and you know about area, it is units squared. But wait, it's a three-dimensional figure. Yes, but you're not measuring volume. Volume is a three-dimensional measurement. Area is a two-dimensional measurement. Surface area is a two-dimensional measurement of a three-dimensional solid. So I'm just measuring how much paper is going to go around the outside. That is surface area, so my dimensions are squared. Okay? Pause if you need to, play back if you need to. Otherwise, we're moving on. Turn the page. Work with a partner, draw the net and label the parts of the cylinder and the measurements, then complete the table to find the total surface areas for exercises 1 and 2, round to the nearest tenth. Okay, I'm your partner, lucky you, as always when we do these videos. So draw the net means I need to make a flat two-dimensional representation of the three-dimensional solid. These are cylinders, right? So hopefully by now you understand that when I have a cylinder, I'm going to have two circles and I'm going to have a rectangle. It doesn't really matter to me how you have these connected. Most people would say, well, if you're going to keep it laid out just the way that it is, imagine that this top flips up and flips open, the bottom flips open, and we just unroll the piece in the middle. Okay, so if you did that, you would have a shape that looks something like this. My 8 inches would be right here because that's the height of the cylinder. This dimension of the rectangle would be the circumference of the circle because that's the part that's being rolled out. And then you would have one circle up here, not a great drawing, and one circle down here. Not a great drawing either, okay? But you get the idea. So the idea being now, I need the dimension of this across, which we said was pi times the diameter. The diameter is 4, so that means this is 4 pi. We'll get to that calculation in a second. Okay, here's the circle. The diameter is 4, which means the radius is 2. The area of the circle is pi r squared. So this is pi times the radius of 2 squared, and I have that for both circles. So you could either calculate this area and double it, you could calculate them both and add them together. I think it's easier to just double this one. And then we need to calculate the area of this, which very simply area equals length times width, so it's going to be 8 times 4 pi, and then we can do the actual calculations at the end. So this is going to be 8 times 4 pi. Then I would need to add it all together. So 2 squared is 4 times pi, so this is 4 pi. Which is 12.6, rounded to the nearest tenth. That means this is also 12.6 down here, rounded to the nearest tenth. And then all I'm left with here is 8 times 4 is 32 pi, which is 100.5. So I've got my three shapes, 100.5, 12.6, and 12.6. Then I need to take the sum of the three of those. And I get 125.7. Inches squared, because it's surface area. 125 square inches for the oats container. Hopefully that makes sense. If you need help, go back and review that. Again, this is an intro, so we're just kind of showing you the visuals and the calculations. We'll get into the actual formulas when we teach the lesson. So, but for right now, we're more concerned about the individual area formulas so that we can calculate the overall surface area. Okay, so can we fill in the table for 3? We can. Area of the top, pi r squared, that's 12.6. This is 12.6 also. The curved area, okay, so that's the area of the rectangle. We found that to be 100.5. And our total area was 125.7. centimeters squared, or inches squared, sorry, inches squared. Okay? These are all inches squared, by the way, because they're all areas. Area, 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 area. All inches squared for labels. So why don't we do this? Let's give you a few minutes to try the second one on your own. Pause the video and come back and check it with mine when you are ready. And we're back. Here's what your diagram should look like. Circle on top, circle on the bottom, rectangle in between. The diameter is 10, the diameter is 10. This side length is the height of the cylinder, which is 25 centimeters. This is the circumference of the circle, which is pi times diameter, pi d, 31.4, 3.14 times 10. If you do the calculations of the individual shapes, it looks like this. Each of the circles is 78.5 centimeters squared. That's from the pi r squared. The radius is 5 if the diameter is 10. So be careful with that. Diameter of 10, radius of 5. It rounds to 78.5 to the nearest tenth. The area of the rectangle would be 31.4 times 25. That is an even 785. And if you add all that together, you get a nice even 942 square centimeters. Okay. So that being said, I think did we already calculate number 5? That's kind of the intent of this as an intro. So you have completed this. We're not going to worry about the 6 and 7 right now. What I want you, or actually 5, 6, and 7, I want to make sure that you have an understanding of where these numbers came from. So if you need to go back and review that, please do. Otherwise, I believe you're prepared for lesson 8.4.